Hello everyone, today I'm going to discuss about an important topic of inorganic chemistry, which is concentration related mathematics. So dear students, hope that after watching today's class completely, it will be very much helpful about concentration related mathematics. So let's start today's class. Suppose there is a beaker which is containing 500 ml of water and their sodium carbonate salt which is 50 gram, say. So this is the volume of water and the sample of sodium carbonate, which is also called washing soda, which is 50 gram. Okay, let's say the data has been supplied for you. Volume of water, V means volume. The volume of water is 500 ml. Okay, the molecular mass of sodium carbonate. We know that to express molecular mass, capital M is used. So the capital M is sodium carbonate will be, the atomic mass of sodium is 23. You know, there is 2 sodium, that's why it will be 23 into 2 plus the atomic mass of carbon is 12. The atomic mass of oxygen is 16, and since there is free atom of oxygen, that's why it will be 3 by multiplication. Okay, the total calculation is 106. That means the molecular mass of sodium carbonate is 106. Okay, after using the atomic mass. And the sample of the sodium carbonate is 50 gram. That means it is the value of W for weight, which is 50 gram. So there is an important formula you know already maybe, which is W by M is equal to S into V divided by 1000. And that's the basic formula to determine the concentration. Okay, the concentration is expressed by S or C. You can use S or you can use C also. Okay, so if I want to get the S, I have to take it here. S is equal to V into M, and here is W into 1000. So I have to use the value of this data. W is 50 gram into 1000. The value of V is 500 and the value of capital M is 106. So can get 50 into 1000 divided by 500 and divided by also 106. So 0.943, and the value of S is 0.943, and the concentration is calculated in capital M, that means molar. Okay, because of it is in molarity also, and you know the molarity means mole per liter. Okay, so we can get the value of concentration by this way. Okay, there is a point that if I add more 100 ml of water here, what do your common sense say or describe? That if you add more 100 ml of water, the concentration of this solution will be increased or decreased? Definitely will be decreased, because of you are not increasing the amount of salt, you are just increasing the amount of water. That's why you can use any drinks, soft drinks. If you add just water after water, the concentration will definitely be increased rather than decreased. So we can use this formula to determine the decreased or increased concentration by this theory or by this formula. How? If I add 100 ml of water more, the volume will be 500 plus 100 ml, and that will be 600 ml of water total. Okay, the molecular mass is like 106, and the sample is 50 gram. Okay, notice that you have just increased the volume of water, not the amount of salt, supplied salt. So we can use again W by M S V by 1000, or S is equal to VM W into 1000. Okay. Then what will happen? Just notice the value of W is 50, saying 1000, and the value of V is 600 ml, and the value of capital M is 106. Then let's see what will happen. 50 into 1000 divided by 600 divided by 106. Okay, 0.786 molar. Okay, in my previous math the value was almost 0.943. Look that which one is greater, 0.943 or 0.786? Definitely 0.76, because of it's greater and it's the smaller value. Since it's smaller value, that means the concentration has been decreased already, and because of what? Because of you have already added 100 ml of water already. That's why the concentration has been decreased. So you can determine the concentration of any solution by this formula. So you can understand, it's a really easy way to determine the concentration. I think that after completing today's class, after watching today's class, it will be very helpful for you. So bye bye. Hope that you will practice it more and more. Okay, thank you.